So, hi everyone, welcome back to Standing on Business. We are still your hosts. Today we have a special guest with us here. His name is Julius. He was my mentor when I did a program called H-Prep, where they introduced us to various health professions and research fields and different routes someone could take, like MD, PhD, things like that. Great mentor, great essay writer. We're very glad to have him on here and to talk about his career trajectory a bit. So,
Hi, hello.
Hi, Julius.
I didn't realize when you were doing the intro, I was like, wait, I'm going to have to do an intro. I'm going to have to say hello.
yeah, I guess that's true.
Wait, do I have to say hello? Hi, guys. I'm the co-host. Okay, we're good.
Perfect.
This is
ideal.
Great. This is great.
Ideal intro.
This is so funny. But yeah, so I guess, I don't know, do you have a quick introduction about yourself that you happen to have ready?
Ready. I don't know about ready, but I can introduce myself. I'm Julius. I'm a third-year graduate student at Harvard University. I'm in the Organismic and Evolutionary Biology department, and I work in the lab of Dr. Carolyn Elia. We study zombie flies that are infected with a fungus, gets inside them, goes into their brain and takes over their behavior. And so I'm trying to study the molecular basis of that, but I think broadly I'm interested in kind of everything, but especially behavioral genetics. How do small, sort of relatively simple things like genes or base pairs, these sort of chemical responses, translate to such complex things like behavior. So that's sort of my general interest.
Awesome.
Very cool.
It's a pleasure to have you here, Julius.
Pleasure to be here.
So, I guess some context about our podcast. We kind of try and gear it towards people like me and Vanessa, like in the beginning of their careers, starting up maybe in high school or the beginning of their college career. So, I guess to bring it back to that, I'd like to ask you, what was it like for you in high school? Like, what were your interests, and how did you bring those interests to your college life and your future career?
Oh, that's a good question. Yeah, I think this is a great format or a great place to target people, because I think high school is where, at least for me, a lot of my interest in biology really coalesced into this is what I want to do for a career. I mean, certainly plenty of people take even longer to figure things out, and that's totally fine. But I think high school is such a great place to explore and try and figure out those interests. And so, yeah, for me, I mean, I was going to say I kind of got lucky because my dad is a biologist, that I was able to get some early biology, given that that's my interest. But I don't know if you can tease that apart from that being my interest, because I'm sort of, it's what your parents do. I mean, my sister was the opposite way. She saw my dad being a biologist and was like, nope, no science for me. So I guess, but that was at the early stages. My dad imparted a lot of that to me pre-high school. But when I got into high school, I think what really made the difference for me was actually going and doing research and seeing it's not just, if you go to science class where it's sort of, all right, memorize these facts, flashcard. It doesn't really give an accurate picture of science. It's sort of like, here are the things that are right, and here are the things that are wrong. And, maybe you learn a little bit of the history, but you don't, the scientific process of total failure over and over and over again with this creative, fun element. I think, people kind of make that distinction between science and art in school, whereas I feel science is kind of one of the most creative things you can do, and it's sort of it's a shame that there's that split. And so actually going into research was, to me, the first step towards that. So finding a research position in high school, mostly doing schoolwork, but during the summers doing research and things like that, I think really enhanced my ability to sort of see myself doing that in the future as a real genuine career. And then, I can, I guess, talk more about college if you'd like, but I think that it was that beginning part that once I came to college, it was kind of a no-brainer for me to go right into research again, continue doing that. So yeah, I guess that's the short version of that
That's
answer.
pretty awesome. That's pretty
That
awesome.
is
That was
so
a
cool,
very
and I like.
relatable answer.
Yeah. Yes. Oh my God, that's what I was thinking. I really resonate with what you said because that's what I didn't realize because it's like as you said, as students we memorize things, we learn rote. We don't necessarily learn like research skills. That's the thing that amazed me most during my internship was just the amount of initiative science takes. It is surprisingly improvisational. It is, and it requires just so much confidence and creativity. And that's what I've noticed when seeing my mentor work, which I mean, I'm not interested in what she does, which is focused ultrasound, like just like career wise. But
Yeah.
it's so cool to see, just how smart she is, and because she is both smart, like academically, obviously, she's a postdoc, but she can think outside of the box in so many ways. She is so quick-witted. She is just like it's just like inspirational to be around her. You know what I mean? But yeah, that's what's like struck me most about the scientific process was that it is so improvisational in such a way that I had not known prior.
I really
Yeah.
agree. I love that about I love that about like working with my internship. I feel like school is way too formulaic. Like there's always a right answer, there's always a wrong answer, and I mean, in some ways that is kind of applicable to life, but I feel like especially in the field of science, when things go wrong, things get improvisational. There's like a lot more entropy outside of the classroom that makes it a lot more engaging. And when I like when I gained that realization, when I gained that perspective from like doing some research outside of school, it made me think that it was much more like I could see myself in in an environment where I'm improvising, where I'm coming up with creative solutions like the rest of these people, and I really enjoyed that about my research. So I see where you're coming from, both of you. I really appreciate your insights, actually.
Yeah, and I think I think what I think that that's sort of like a common experience people have, and I also think that the people don't realize, I think, until they get into it, that that's actually a skill you can learn. Like where you were saying, Vanessa, about your postdoc who's like, yeah, has like that, quick wit and is able to like do that, think about things in that way. I think it's a muscle memory kind of thing. You learn how to do it, and I think it's sort of yeah. People kind of think about, if you're at the bench as a high schooler or a graduate student or a undergrad, you're pipetting something back and forth over and over again, and it's sort of like, is this, even there, it sometimes feels kind of rote. It's sort of like, is this all it is? But I mean, well, first, I guess you have to do that at some level, but also as you build that muscle, you get more and more into these, like, I don't know, I guess leadership roles, these kind of, I mean, what are PIs other than like, the ideas people? They just kind of sit there, have ideas, and then people come up and come to them and say, I'm having this problem trying to execute this, and then they think of ideas how to solve that. And I think that they're only there because they've had so much time of building that, that understanding. Like right now, I'm mentoring a couple undergraduates in the lab, and I'm sort of getting a mini version of that, and I find it really fun to do. But I also think back and like, wow, like I think that's where it's like, oh, I've actually come a decent amount from where I started in that skill, because it's like, oh, like I'm thinking of these things in this way that I would not have been able to do before.
Oh, that's awesome.
That's so cool.
I like that aspect that having like a creative frame of thinking is actually teachable, because I feel like school doesn't do that. So
Yeah. I think it suppresses that, if anything.
yeah. For example, our school, Vanessa, I don't think we
Yeah.
can name it, but um, it is like it is a science-based school. We have like a rigorous science-based program, but when we're just learning straight from a textbook, it doesn't feel creative. It just feels like this is the way the universe works, and accept it and move on. And I guess that's kind of real, but like we don't really have any opportunities in a science class to be creative in the same way we would like a humanities class. But it's one thing to know that creativity can still exist in STEM fields, and it's another thing to realize that it's teachable. So I really appreciate um, your insight on that, Julius. And you actually, now that I think about it, you mentioned teaching undergrad students. So I guess like what steps have you taken in your career from high school and to now?
Oh, like I guess like the sort of like the career trajectory kind of thing.
Oh yeah, yeah.
Yeah. Cool. So I started doing some research in high school, and then I think my when I once I found out where I was going to college, I applied to various colleges, and then once I chose where I wanted to go, which honestly wasn't that much of a choice because I only really got into one place. So I was just like, all right, I'm going there. And so I went to University of Chicago, and once I knew I was going there, I guess I found out that a professor, kind of by chance, a professor from U Chicago was coming to speak at Harvard, and I grew up in the Boston area, and so I was nearby. I was like, oh, maybe I'll go see his lecture. So I went to see his lecture, and I thought it was really cool. The professor's Neil Shubin. He works on, I guess if I don't know if anyone's familiar with Tiktaalik, but the first, I guess like the missing link you can call it between fish and land animals, the tetrapods. And so it's kind of has half fins, half limbs kind of thing. And so and he found that was his big discovery, and he was talking about that at Harvard. And so I saw his lecture, and afterwards I came up to him and I said, hey, I'm going to be an undergrad next year. Would you mind if I worked in your lab, or can I come like to you about working in your lab? And he said, sure. And so then when I got to U Chicago, I was kind of like right away in the lab, which I was very thankful for. I think most people don't really do that in advance. I kind of got lucky in that case, but I think most people, like when you get to college, you can just like email professors, either a professor you've taken a class with, or just like you go on the website and find someone that you think is interesting. Most people are really love having undergrads in the lab, and and if they don't respond to your email or aren't really interested in having undergrads, then you probably don't want to be an undergrad in their lab anyway. Yeah, so I started doing research there, and in college I started as a biology major, but I had taken 10 years of French before coming to college, and so I wanted to place out of having to take a language, so to have more electives. And I took the placement test, and I placed into French 102, which was just above basic. Clearly, I learned nothing in 10 years. J'ai oublié, I'll say. And so I looked next to on the languages, next to F for French was E for Egyptian, comma, ancient. And I was like, yeah, I'll take ancient Egyptian, sure. And the more I thought about it the summer before I got to school, the more I thought, but it'd be really cool to take ancient Egyptian. So I bumped it up on like my ranking list, and eventually I got there, and and I don't know how much of this story is interesting, so you can cut what you want. But basically I sat there, and the professor was looking at me, and or she looked around the room, and she's like, well, I see on the sheet that there's an undergraduate in this class on the roster. Just want to let you know that the no undergraduate has ever done well in this class ever. And she's like,
right off the bat.
Yeah, and she's just like, this is a graduate class, and this and I'm not saying you shouldn't take it, but just like know that like. I don't remember what she said, but it's something like the highest grade an undergraduate has ever received is a B minus. Like it's like she's like this you're just gonna take a lot out of you. And then we went around the room, sort of introducing ourselves, and she said. And someone was like, "Hi, I'm whoever. I'm a master's student. I'm a PhD student. I'm a master's student. I'm a fourth year undergraduate. Stuff like that." And it came to me. I'm like, "Hi, I'm Julius. I'm a first year undergraduate." It was my second class in college ever, and the professors looked at me. Her eyes got really wide. She was like, "You need to see me after class." And I was like, oh God. Uh, so we started learning it. I thought the material was really interesting, in that class. But afterwards, I went to see her, and she was very nice, but she said, like, look, like, this is going to take a lot of work. This is for grad students who are taking like one or two classes. Like, if you're an undergrad taking four classes at a minimum, you just aren't going to have the capacity to work this much. Like, and you're a first year, and this is like, and the more she talked, the more I was like, oh man, like I gotta drop this class, fine, I'll switch back to French. And then she like looked me in the eyes, and like in a nice way, but still she was like, you can't do it. And immediately I was like, well, now I have to, because I can't walk away now. And so she was like, but look, I believe in academic freedom. I'm not going to kick you out of the class. You have to leave of your own volition. And I was like, see you on Wednesday, I guess. Like that, I couldn't say anything else. And so I took the class, and to the detriment of maybe some of my other classes, I worked really hard at it, because I was like, I got to prove her wrong. Like, I can do this. And I think, again, there's a little luck involved in the sense that I think I took to ancient Egyptian in a way that, for whatever reason, I didn't take to modern languages. I wouldn't say modern languages, because my high school forced me to take Latin for a year, or for 2 years, which is that's a whole nother thing. But I was not good at Latin either. But for whatever reason, ancient Egyptian like really came to me, because I think it's because it's very much a puzzle. It's I mean, it wasn't to the ancient Egyptians, I guess, but to the modern reader, there's, it's really hard to just read a sentence, because there's so much to decode and so much to, like, there could be a million different interpretations of each different word and of the grammar. And so you kind of just have to piece it together with context. And I really like that way of thinking about language. And so it came to me, but also it was a lot of memorization. I mean, there's over 700 different hieroglyphs. And that's not to mention all the different words and things. And so, but I took it, and I got an A in the class, and she wrote me a very nice handwritten apology note of like, shouldn't have told you to drop the class. But I actually think if she hadn't told me to drop the class like that, it probably would have gone a lot worse, because it's that. And I think that's a fun story, but I also think that the lesson there for me was like, I mean, it kind of sounds like, live, laugh, love, motivational quote style, but like that sort of like, set your mind to it and you can do it kind of thing, where it's sort of the exploration in, like, I would never have thought I was going to study ancient Egyptian in college. And I think that was proved to me. I was like, oh, you're not bad at languages. You just have to find the like way to do it that works best for you. And like the sort of the field. And what I like about college is that exploratory component. So I ended up taking Middle Egyptian, Late Egyptian, Old Egyptian, Demotic, the hieratic, which is the Egyptian cursive. And I took all these different forms, which are all like very different linguistically. And it ended up becoming my language requirement, then my minor, and then my major, and then my primary major over biology. I did my thesis in Egyptology, and that was sort of my, I really got into that. So I did some Egyptology research on my own, and continued doing the biological research in the Shubin lab. And so when I came out of college, I felt very well equipped to go into either Egyptology or biology, but there are a little more career prospects in biology. So then I ended up coming to Harvard. I guess I'll put a pin in it there and toss it back to you if there's anything in that part, because I think I dumped a bunch of info.
No, this is good. Okay, I have two things. One, have you watched anime like ever?
When I was a kid, I watched Sailor Moon and Yu-Gi-Oh! Every time I was sick.
Right now. I'm so happy right now.
Every time I was sick, we had this big, or I say big in a horizontal direction, or a depth. like a cathode ray tube television that we would wheel into my room with VCRs. So I watched these old Sailor Moon VCRs and Yu-Gi-Oh VCRs. A little Pokemon too.
Okay, this gives me some follow-up questions. First of all, I'm so glad you said Sailor Moon because that show is my childhood. That and Tokyo Mew Mew, best shows. Okay, firstly, this one is so unrelated, but who is your favorite Sailor Scout?
Oh, that's a good question. You're gonna have to give me a sec to think about that. I think the main thing when watching Sailor Moon, that bothered me was that not every planet had a Sailor Scout. At least in the section that I had access to at the time. I don't know if I just didn't get all of it.
Yeah, you didn't get to all of it.
Yeah. So do they all have them now?
Yes, they do all have.
Oh, this is good. This is a Google for me then.
Yeah, Sailor Neptune, Sailor Uranus, Sailor Pluto, Sailor Saturn.
I never saw those ones.
Those guys were a reset.
Yeah, Jupiter, Mercury, Moon. Those are the ones that come to mind as like, okay, yeah, I can remember what they look like. I can remember what they were up to.
Wow. You watched the 90s version, right? The original animation?
Yeah, all VCR.
Yeah. You've never watched Crystal, I assume. They remade it like 10, 15 years ago, I want to say. Yeah. Wow. That's like I'm so delighted by that. Very few people share my Sailor Moon obsession, but it was my childhood, my favorite show. Okay. That's my unrelated question. But what I meant by the anime thing is that in Japanese like pop culture, the main character's superpower, beyond anything else, is determination. They can do anything as long as they set their mind to it. They can learn to wield any ability. They can simply do anything. The power is derived from the determination and will to do it. That's you.
Oh, thank you. I don't know if I can do anything, but
I guess you have to try.
That's true. But I do think determination is a important skill. Like, I think one thing that I ran into when I got to college was like the freedom suddenly blows up, and it's sort of like because high school, as you said, there is some rigidity there, and some of it's important because you have to learn facts, like to just have a knowledge base to build from. But I do think that like once you get to college and suddenly you can take any course you want, it kind of like is like, whoa, you totally have to change, or at least I had to totally change my like ways of learning my skills, like because the high school skills weren't really serving me there. And then getting to grad school, the freedom is like, okay, now I only took 4 classes, and now I'm, and sometimes I'm teaching classes, but I'm mostly like doing research, and the freedom is so much greater. And at that point, I have ADHD, and I realized that like the strategies to manage ADHD as a college student, where I was like, yeah, I can kind of like, like for instance in college, like I would have days where I'd be super productive. I would get like 100 things done, and this sort of hyper focus, and then other days I would be like, I can't focus on anything. All right, this day's shot. I'm just gonna give up on that, whatever. And that worked for me. In here, where I can't really knock out any research project in a day because they're so, that's I guess my life. So I realized I had to totally change the strategies I use. So I think that the determination, I think, is exactly right. It's like a determination of like not just keep bashing your head against the brick wall, but trying to figure out like how can I leverage determination in this way? Like I guess the determination to succeed, in whatever way is best. I think that's sort of it's the flow of the river along with the strength of the river. If that made any sense at all.
Oh yes, I too am familiar with the Mulan movie.
Yeah.
So that I need you to talk about this because this is one of the coolest instances of transferable job skills I've ever heard. Your hieratic thesis.
Yeah, I can definitely talk about that. So my so I took hieratic in I want to say my second year. Yeah, it was my second year. Yeah, right. Because I didn't get to take my hieratic final because we got
What is
shipped off
hieratic?
for COVID. Yeah, good question. Hieratic is the Egyptian cursive. So
Oh, okay.
if you have, well, frustratingly, there's hieroglyphics, cursive hieroglyphics, and hieratic, and they're and so when I say it's the Egyptian cursive, it is, but it's not cursive hieroglyphs in what we talk about. So like if you everyone knows about, you go and you see the hieroglyphics on the tomb walls. If you go into like a museum and you see a Book of the Dead, where you see like, it's this big scroll of papyrus, you see these like figures on the Book of the Dead, those are cursive hieroglyphs. And so they're kind of like, you can usually tell what if you know what a hieroglyph looks like, you can usually tell which cursive hieroglyph goes with it. Hieratic is like an even more stripped down. It's like the doctor handwriting of hieroglyphs.
Ah,
It's sort of
okay.
that, I mean, I think it's very beautiful, and it kind of, especially once you get into these later periods, like if you look up New Kingdom, especially the Ramesside, like in the periods of the period of the various King Ramses, Ramesside hieroglyphs, they're like drawn down with these swooping strokes, these beautiful sort of Arabic-like strokes. But they are very much not one to one. I mean, they're one to one in the sense that there's one hieratic symbol for one hieroglyphic symbol, but it is not clear at all which are which if you don't know. And so the way Egyptologists tend to learn about hieroglyphs or learn hieratic, is they have this big book written by Moeller in 1909, and it's this big book where basically Moeller put all of the hieroglyphs on one end of the page and all of the hieratic glyphs on the other end of the page, and you just basically memorize this is what hieroglyph corresponds to what hieratic symbol, and he has the hieratic symbols over time, like an example of it from each time period, and so you can, because the hieratic symbols changed much more than the hieroglyphs did. And so you kind of had to sit there and memorize it. And I did not have a good time with that. My memory is not very good. And so I was like, well, why isn't there, like, is there a program where you can just draw the hieratic symbol and it'll show you the hieroglyph? And they kind of looked at me and they're like, no, like, that's would be really hard to code. And even if you did want to code it, like, where are you going to get this data set from? And so there's some pictures of papyrus online, but like it's not digitized data set wise. So immediately I was like, all right, time to create this thing. So my first one was like in a Google spreadsheet where I like had Moeller. I like basically made the Moeller thing into like you click check boxes based on what your glyph is like. It's like, oh, mine has a big loop at the top, and then all of the ones that had a loop at the top would go to the top of the spreadsheet. I was very proud of it, and they let me use it during tests because you could bring your notes in, and they were like, that's
That's
effectively notes.
amazing.
But I realized that it needs to be better than that. So I digitized a bunch of material. So for instance, Moeller, he also had a bunch of facsimiles, so these sort of copies of ancient Egyptian texts. And the reason I used copies was because the original text can like have damage or like are like grainy images. So these are like high quality recreations of them, and I cut out each individual glyph, and I did that through a collaboration with a guy named Christian Casey, who I'm still collaborating with right now, actually. But he helped me have a program that just cut out all the glyphs if I just outline them in Photoshop. And then I also realized that the data set needed to be bigger because I don't want to just identify Moeller's glyphs. I want to identify the underlying Egyptian. And so I took some other people's facsimiles and I created a bunch of my own. So I sat there for like 500 hours and made my facsimiles. I like drew them myself, in Photoshop digitally. And then I realized it's not good enough. At least I didn't feel it was good enough. So I went back and did them all over again. So it's like I redid that another 500 hours, but what else are you going to do during COVID? And
Yeah.
yeah, and I had this big data set. And then so to get at what Vanessa was talking about with my transferable job skills is I realized that I thought it would be really cool to have a method of, if you have this big data set, not only can you make like a program that kind of, learns from these glyphs, use machine learning, and like can predict, if you draw something, which one is it most similar to, this optical character recognition. But I also thought that it would be really, if you can draw a glyph and it'll tell you how similar it is to any other glyph, then you could also say how similar each one is to one another in the data set and make this big connected web. And if you could do that, you sort of have like a similarity metric between different hieroglyphs. And I remembered in the Shubin lab, I was doing this single cell RNA sequencing where I don't know how much to get into single cell, but you basically take a tissue and you run it through, you kind of dissociate it, and you have each individual cell barcoded. And the barcoding is basically just to say, this cell is unique from this cell and stuff like that. And then you run it through, and then it identifies every cell, and it says what is the gene expression, or really the RNA expression, which translates to gene expression in each of the cells. And so then you can compare, and it's like, oh, okay, if you cluster all of that data, all of the cells that have a high expression of, say, hemoglobin are all clustered together, and you say, what are all those cells? Well, if they have a high expression of hemoglobin, that is hemoglobin's almost only expressed in the blood at that high level, and so those must be blood cells. And then something else might have a high expression of some other gene. It's like, oh, it's clear those are fat cells, or you can kind of cluster them like that. So I was doing that with fish fins in the Shubin lab, and I thought that would be a really cool thing to transfer with the hieroglyphs, because we have this similarity metric that is based on the pixels in each symbol, and so that is our gene expression, as you could call it, and each individual glyph is one cell, and then the tissue it came from is the original text. And so if you just port that framework over, and I took directly those tools from single cell, especially these dimensionality reduction graphical things like UMAP, I was able to cluster the glyphs, and I think it was a really cool way to get insight into hieratic and its development. And so, one example of that is there's a hypothesis that there were these two texts that people had hypothesized, they were written by the same person. And there had been some work where they had looked at the shape of the strokes, and they're like, this really looks like the same handwriting. But they didn't really have a statistical basis for that. It's sort of like, it's just, it really seems like that. Since I had the whole texts totally transcribed, you could say, okay, let me look at every version of, the one really common glyph is the seated man. And you say, okay, every seated man in text 1, every seated man in text 2, and let's throw them on the thing. If they were written by separate people, you would expect totally separate clusters, or maybe a little overlap by a fluke or something. But if they were written by the same person, they should be right on top of one another. And that's what you see. You see the latter, and it's sort of like, okay, this hypothesis about the origin of these texts, is true. And it really seems like these were written by the same hand. They're clustering right on top of one another. And I think that kind of, insight into the humanities through these sort of STEMish things is, to me, one of the most important parts of sort of this interdisciplinary learning and interdisciplinary, I guess, just experience, is being able to port stuff from one subject to the other. And I think I definitely learned a lot from Egyptology that I can apply to biology in terms of how to think about things in these sort of, less kind of stringent way.
That was awesome.
That's great. That's so cool. Also,
That was
you
so cool.
3 weeks ago, right? You said to me that you got it onto a website.
Yeah.
How? Wait, can you send us the link? We'll
Yes. Sure. I don't know how interesting. So the program's called eSuit, and I don't even know how to send it. I don't know if there's a chat, but actually I'll send. Yeah, I can send it in the email too. But that's easy.
Oh, awesome.
But so it's got all the texts and most of them. Right now it's mostly Moeller and me. Although we just recently, since we last talked, got a new collaborator who's going to add some late Egyptian text, which will be great because we're mostly doing Middle Egyptian. And when I was talking about those Ramesside strokes that come down, I would love to see how those developed over time. And I think it's expanding because what I want this to be is a tool for Egyptologists to broaden their broaden the data set and then be able to make all these sort of cool comparisons, in different ways. So I think as someone who's listening to this podcast who's not an Egyptologist, I'm not sure how interested this will be if you don't know the hieroglyphs, but if you go to the guesser, you can draw a symbol and click enter, and it'll show you its predictions about what it thinks the sign is. And so I'm really excited that this exists now because this was what I was working towards, and it took my thesis, and then from that collaborating with Christian Casey and Mark-Jan Nederhoff, who are two people who I reached out to originally who had done some kind of early work in this space, and I think it's kind of taken off. So when people ask, what do you do in your free time when you're not researching? I'm like, well, researching something else. And just kind of go home and, work more on Egyptological stuff because I think it's so cool.
That is so cool. Yeah. I don't know. Talking with you really changes my perception of Egyptology because my only concept of it prior was I'm going to be so serious, Indiana Jones.
Yeah, well, Indiana Jones actually, in the movies, went to University of Chicago, and he still gets packages to the Institute for the Study of Ancient Cultures, which when I was there and when Dr. Jones was supposedly there, was called the Oriental Institute. So I'm kind of glad they changed the name, but they always get packages addressed to him of like whips and of hats and things like that. I don't know who's sending them, what they think is going to be, what they think the outcome will be. But
is it like a gag gift, or is this like fan mail?
Well, like, yeah, I mean, I assume it's a gag gift, but like, I don't know what, like, do they think like the person who runs the OI, or I guess the Isaac Museum, is going to look at it and be like, oh yeah, like this is funny. Let's, I gotta find this person who sent us the package and like invite them here. I have no idea, but
that's amazing.
But yeah, there is that same perception.
It's a consistent sender, or it's multiple people. This is amazing to me. This is great.
I have no idea. They get a lot of different interesting. That's probably the most innocuous thing that that the Institute gets. They get a lot of calls and about people being very angry. Some for perhaps important reasons, and some for less important reasons. I'll say.
Interesting.
I've been playing with the guesser in the past 2 minutes. It's really fun. I've just been scribbling, and it'll give me like a percent match with around like 6-7 hieroglyphs at a time, and I think it's really cool. This is awesome.
Yeah, and thank you. And I think I mean, I guess at the moment it's not. I guess what I want for the future of it, one thing I would want is to show the hieratic symbol it thinks you're drawing to, in addition to the glyphs. Because right now, as an Egyptologist, like I can draw a symbol, and if it spits out a hieroglyph, I can, I guess, check it myself. Like, oh, that looks right, or that looks wrong, but it doesn't really tell me what the program thinks I drew, in the sense that what hieratic sign it thinks I drew. Unless you know the hieratic signs for all of this. So there's definitely improvements to be made, but I like that it also gives a confidence score, because originally I had it as giving like the top answer, and it was not always correct, because one thing I found is that glyphs that are distinct in hieroglyphs are not always in hieratic, which is a cool feature of the language. You can learn a lot about what the people valued in that sense. What was it important to them to see those glyphs as the full things.
Very cool. I don't know. I've like hogged you for a little bit, Nathan. Do you have questions you've built up or?
Well, I mean, they usually get answered. I don't know. I don't know if you've also been looking at the plan we had for this episode, Julius, but you keep hitting every point without me asking. Like, thank you. But that was, I mean, I don't have much to say other than that was really cool.
Yeah, it's just really cool. I guess then the main thing we're wondering about is more about your time as a PhD, because that's like very mysterious to us as high school students, because like we have like some understanding of college. We've had some friends who've gone to college. Nathan has an older sister, but PhD, like, we're very curious. What does that like include?
Yeah, absolutely. So yeah, I guess I will also say I totally forgot there was an agenda for this, so I'm glad I've been hitting it. But the yeah the so the PhD, I think it is kind of esoteric, because people, when they think about grad school, I think, at least what I thought of before really getting to know PhD students, doing research, I kind of thought of it in a similar way as, med school or law school or business school, where, you go there, you pay a bunch of money, and then you get a degree that, presumably will help you in your future career. Either you get a higher paying job, or you get some skill or something like that. But it's really like, it's sit down at school. It's like more college. But that is not the case for the PhD at all. First of all, the big thing that I think a lot of people will be happy to hear is that they pay you. I think maybe not as much as they should, but it depends on who you ask. But they do pay you, and when you go to do your PhD, it's a job more than anything. You're there to do research, as a professional, and there is, you're still a PhD student at the beginning. You come in, you're a student, so you do take classes. Depends on your program. Like I said, I took 4 classes, but some programs you need to take, 8 or 10 or something like that. Like totally depends on your program. And then you take classes, and then in your second year, you have a qualifying exam, and qualifying exam totally varies for program to program, but it's kind of like a prove to us that you can work independently, that you have the skill set, to do this, I guess. And so my qualifying exam took the form of sitting in a room with a bunch of professors, and they kind of grilled me on my proposed thesis. And so they, asked me a bunch of questions on that. I also had to create some syllabi. I don't know of another program that makes you create syllabi for proposed classes, but some other programs have like a practice grant that you have to write, or you have to do a sit-down test. And I can really only speak to biology, but I think most of them kind of take that form of something, and you sit in a room with professors while they grill you, and they try to get you to the point where you say, I don't know. And then, it's because they really want to see the limits of your knowledge. Are you ready to be an independent scholar? You're still working in someone's lab, so it's independent is, only goes so far, but it is definitely a milestone once you pass that. So you do that in your second year-ish, and people generally think of that as basically being a master's. So you get your master's when you do that. So most people don't actually take the master's. So if I wanted to, I could, say to the school, yes, give me a master's, and then I continue on to get my PhD. Most people don't actually do that, because they just wait until they get their PhD. It's like, I'll just do that at that point. But if you leave the program after completing your qualifying exam, then you just leave with a master's. Like once you pass your qualifying exam, they can't take the master's from you. So I think that's another thing that people often don't think about is, because you do have to pay for a master's, but if you do a PhD program and then leave, or not leave, you get your master's and they pay you for it. So that's a nice part of that too. Although definitely, if you only want to get your master's, don't apply to a PhD program and say, yeah, I'll leave after the master's, because they will not accept you for that one. But yeah, so I think, as I said, it's a lot of freedom. It's a lot of working. You work in a lab. If you, at least for biology, most of the programs are rotation programs. You come in, you do some, 5 to 7 week rotations in a bunch of different labs. You get to know the lab, you get to see the research, so you get to try out a lot of different things, and then you choose the one you want. My program is an evolutionary biology program, and due to historical reasons, they're usually direct admission. So I knew what lab I wanted to go to. I applied to that lab, and I went directly in, started right away. And when I started in the lab, it was sort of like, all right, I'm going to be here for 6 years. Yeah, I guess that's the other thing. PhDs can be very long. So the depends on what you're doing. If you're in like a more biotech or biophysics kind of molecular biology kind of programs, you could graduate earlier, especially like the computational people. Like I know people who've graduated for the PhD in 3.5 years because they just went zipping, doing like bioinformatics work. That is not going to be me. I will be. I don't want to jinx myself and say over 6 years, but I'll be here for 6 years, I think. But I don't mind.
Or like,
What?
what year are you on now?
I'm in my third year, so I guess I just started my third, so I've got 4 years left, 3 through 6, and so yeah, I think I find it really fun. I'm not really in a rush to leave, but yeah, I think that's sort of to me, the distillation of the PhD is that it's really fun, and I think if you are going in, when you go into a PhD, you're kind of saying, yes, I'm going to be for 6 years, going to work on these, in this sort of setting. I really want to follow this passion of research, and the downsides of the PhD are that it is, the hours are relatively long, or they can be. I mean, hopefully you still have a work-life balance, but PhD isn't known for that. You're going to have low pay generally. Although, again, better than, at least to me, better than paying for other types of programs. But I think the community, to me, is what makes it. At least, I mean, depends on your department, but my department's super supportive, super, excited, and you're among people who are really like-minded, which I really like. It's people who are, not everyone wants to be a professor when they finish PhD. They, some people want to go into biotech, some people want to do conservation, but everyone has this deep interest in knowledge and learning in this sort of, in this way that I didn't really get at every stage before this. Whereas here, it's like, even the people that I know who are the least happy in their PhDs still have that, spark there. Not that you have to have it, but I think if you don't have an interest in that deeper way, maybe something else is for you. You can make more money going straight to biotech in a different position. But yeah, I think it's the freedom for me. Like, I guess one anecdote I'll say is I took this course from Professor Scott Edwards, who's an ornithologist at my department, and he was teaching these phylogenetic methods. And so for anyone who doesn't know what phylogenetics are, it's about studying the relationships between organisms, projecting backwards, looking at like what were the ancestors of different organisms, which ones are closely related. Like, phylogenetics is how we know birds are closer to dinosaurs, or related to dinosaurs in that way. And so I took this class about these sort of methods for studying it. And I took it because I thought it would be interesting and my friends were taking it. But honestly, it had nothing to do with my research and still has nothing to do with my research. And so I was like, when am I ever going to get to use these skills? And then Scott had this project at the end of the class, which was, go into the literature, find some data that someone's published, and use some of the methods we've learned in class on that problem. And I thought that was a really cool assignment to sort of, get into that. But it also, to me, I didn't feel, I guess I didn't feel like I really wanted to just replicate something that was already out there. And so, again, but it's about the freedom and about taking the initiative. And so I said, well, I can collect my own data set and then run this program. And I looked for interesting problems that people hadn't solved before or looked at before. And I found that no one has ever done a phylogenetic study of eye color except for in humans and domesticated animals, because humans have varied eye colors for sure, and domesticated animals, like you think about your cats or your dogs, we bred all these different eye colors into them, or selected them for them. So like huskies having these bright blue eyes. Most wolves don't have those bright blue eyes, but we made it so huskies do, over many years. And so, but in the wild, people kind of think of animals as having the same eye color. So take a look at any picture of a hyena online. Every hyena is going to have dark brown eyes. Every mongoose is going to have dark brown eyes. Every genet, every civet, every linsang. And I mention those because those are the closest relatives to the felids, the big cats, and the big cats do not follow that pattern. And no one had, I mean, I'm sure people have seen this before, but no one had looked at that in that eye color, looking at eye color in this phylogenetic way, because it's really hard. Eye color doesn't get preserved in museum specimens. Eye color doesn't get preserved in fossils. And if you really want to learn something's eye color, and like if you're in the 80s, how are you going to find something's eye color? You got to go find cats all around the world. No one's going to fund you for that. But now with the internet, you can just look up pictures of cats. I'm very glad I did this before the proliferation of AI images, because I don't know how. I would have to do a lot more data curation, but I got these reliable pictures of big cats looking straight ahead, cut out their irises of their eyes digitally, and used a program, again using kind of these similar clustering algorithms. And I think this is where single cell methods went to the Egyptology, and now I'm moving them out of Egyptology back to biology, but using that Egyptological sense of them, the recontextualization of those methods that I used for my thesis in Egyptology allowed me to use them for looking at eye color in this way, and then using these methods to project back and say, okay, what was the eye color of the ancestor of the big cats, and not just predicting what it would have been in was it blue or was it brown or things like that, but also because eye color color on your screen is from 0 to 255, like that's for RGB values. Mm-hmm. Using each of those and projecting it back in a direct way, so I could figure out like what the exact color was. And I say exact, there's some error bars there, but like quantitatively, like it probably was about this color. And I think that, fingers crossed that study gets published soon. It's getting there. It's in the what I hope is the final round of review. I shouldn't say where yet, in case it doesn't get in, and also the journal probably wouldn't be happy with it. But it is a preprint online if people want to read it. But I think that kind of freedom from taking a class and then eventually getting a publication out of it is sort of and really adding to our knowledge of the world is something that I can only see happening in grad school, unless you're a really precocious undergrad or high schooler. But if you are, like, Nobel Prize for you. But I could not have done that at that stage.
That's so cool. That's so
awesome.
cool. Okay, so while you've been talking, I've generated a little list of questions. So firstly, do you have summer vacation as a PhD student?
Depends on your advisor. So you work because it's a job and not school. Like you have break from classes in the summer. So, and when I say break from classes, I don't just mean taking classes, because as a PhD student, you often teach as well. So I'm not teaching any classes as a TF, or TA, if you go to a school that's not being pretentious. I but so you don't have those responsibilities, but usually people just take that empty space and put more research there rather than taking a big vacation. But it really depends on your advisor. Hopefully your advisor is understanding and you can take breaks. And that's a different part of the freedom of it, not just intellectual freedom, but also, like my working hours are whenever I want because my advisor doesn't care when I'm in the lab. She only cares that I'm actually getting stuff done and, progressing the research and progressing my own development. And so, I tend to work. Right now, I'm working a little more than I probably should be, but I'm working like 11, or I'll come in at 10:30 or something a.m. and I'll leave 12 a.m. The other 12. But so like I'm working, that's like that's close to 14 hours a day. That is not, I would say, I would say not everyone does that. Not most people should not do that. But I'm doing it currently. But hopefully when I tie up some of these loose end projects, I can make that go down a little.
Work.
Uh, I don't know. I mean, after this, I'm going into lab for a couple hours to do some infections of some island flies, and I
Yeah,
don't
you
know how long
mentioned.
that'll take. But yeah, I would say I work many many hours a week, I guess I'll say. But
Yeah, for sure.
I don't want that to discourage anyone from going to grad school because that's all my own free choice. And so, for instance, I'm going to be, I went to my advisor and, I'm going to be out not working for the next few weeks. Well, I guess I don't know about how long that'll be, but basically whenever I recover from the surgery I'm getting. And I didn't have to go and say, like at a lot of jobs, you go and say like, hey, can I take this time off? Put in your request for time off. I just went to my advisor and said, I will be gone these days. And she was like, all right. And I think that's the flip side of the coin where, sometimes I'm working 14 hours a day, but that's because that's because I want to, and I'm interested in it. I'm working that long because it doesn't feel like work. It's fun. It's really it's exciting to me. But first of all, again, to emphasize, you don't have to do that, and probably shouldn't in the grand scheme of things. But also the you can take off and say, I'm going to take this weekend off, even if you're not. I mean, in this case, it's a medical procedure, but I've definitely taken time off to go see friends who are, college friends who live in a totally different part of the country than me. I say, yep, I'm going to be gone this half week to go visit them. It does not. You don't have to plan ahead all that much to do that, or I mean, it's nicer if you do because then your coworkers can
Adjust.
can adjust if they need to, but for the most part, so there's no explicit vacation, but there's a vacation in the sense that you can really do whatever you want hours wise, as long as you're still getting stuff done, and you don't. There's no paid time off or not paid time off. You're just always you have a stipend that always comes, and you don't have to worry about oh, if I take this month off, am I gonna really get paid? Nope, you're still gonna get paid. You just gotta keep progressing. If you're gonna take a month off, maybe you do have to pick up some extra hours during the year just to make sure you're still getting what you want to get done. But it's forgiving in that way, unless your advisor is really bad, in which case you've got probably bigger problems, honestly.
That's so different than school. I'm amazed. I'm
Yeah.
genuinely amazed. Wow. Okay. So my next follow-up. And then after these questions, I'm gonna ask you about your current work because everyone wants to hear about zombie flies. We want to hear about the zombie flies. So you mentioned in your department, it's usually direct admission into labs, and you said it was because of historical reasons. What are they?
Well, it's a good question. In terms of the historical reasons why that is, I don't know what the original difference was, but I do know that if you look around the country for biology programs ecology and evolution programs, almost all of them that are on the older side are going to be direct admit. And I don't know if it was like a discipline thing. I mean, I think this is probably Googleable, or at least like, maybe ask the oldest professor they might be able to say it. But I think I guess for me, for my experience, it has that dichotomy where if you go to like a more newer field, and I think part of it comes from this like old style of doing things where it's like in the European system, for instance, it's very different in many ways. So like, you can go do grad school in Europe if you want, presuming you get in, there's different requirements, right? Like I didn't do a master's before coming to a PhD. In Europe, I wouldn't call it 100% a requirement, but in many places in Europe, it is very much like expected. You have a master's, like an MPhil, before you go and do your PhD. But then the PhDs are shorter, and so there's not really as much of an incentive to rotate around, because like why would you rotate around? If you're going to be there for 3 years, you're just going to go do it. And so I think that maybe some of that is ported over, but that's partly speculative and partly just like thinking about how it my feeling about how things tend to go. But yeah, there is really that split. I like direct admit programs a lot. I mean, I also like evolutionary biology, so I think it's hard to untangle them for me. But I think if you know what you want to do, like I knew what I wanted to do. Like I knew the two things I knew as I was coming back to Boston, because I grew up here, and I like Chicago a lot, but I was like, I'm going to come back, be near family, and I knew that I wanted to do behavioral genetics, and like there was really only one person that like came to mind. I mean, there's plenty of people doing behavioral genetics, like great people in Boston and elsewhere that are doing it. But in the way I specifically wanted, it was really a professor named Hopi Hoekstra. It was clear to me, like she's the person I want to work with. And so, yeah, when I applied, I applied to a bunch of places and then withdrew all my applications except for my application to her. I was just like, if I don't get into her lab, I'll go, be a technician somewhere for a few years or a year or so, and then I'll reapply, because I was like, that's like I could see that's the place for me. I think a lot of people prefer the rotations because they're like, I don't know what I want to do. Let's figure it out. And honestly, the truth is, if you go to a rotation program, you can rotate in the evolutionary biology labs. They usually don't tell you that because they want you to stay in their department, but most places have like these broader programs. Like I'm in the evolutionary biology department, and there's a molecular and cellular biology department, and a biomedical sciences has like all these other departments under it. But there's like a Harvard integrative life sciences, which is all of them, and anyone in any one of them can rotate anywhere else. So like it doesn't really matter at the end of the day. But if you know what you want to do, like I did, it was sort of like, yes, I'm going behavioral genetics, going to Hopi's lab, and so I did. For a little bit, which we can get into when you ask me about, grad school research.
That's so cool. Okay, so this is like my final question before we transition to zombie flies. Do you think you'll ever go for a PhD in Egyptology?
That's a good question. So, I think with Egyptology, I guess one thing is Egyptology is a pretty strict field in terms of how the path goes. So even in the US, you tend to do a master's first, and you don't have to, but you tend to. And in the master's, there are these proficiency requirements. And the way it was pitched to me, which maybe that will be different in X number of years, but it was basically you have to be fluent in English, German, and French. And we already know that French, not my forte. And that fluency is because, unlike biology, where every paper you read is going to be in English, or at least have an English version, no matter what country it came from, no matter who's writing it, and there's sort of that unified language, for better or for worse. But in Egyptology, this is historical reasons, which countries, England, France, and Germany, went down and did all that pillaging really in Egypt in the late 1800s, the early 1900s, and stole all their stuff, and that. Yeah, that led to three different types of publications. Not that they were the only ones who did that, but you get English publications, German publications, and French, and there's nobody wants to convert to the other ones. Like no one wants to like if you're a French scholar and you're writing in French and that's nice. Why would you ever you'd never prefer to write in German or English if you can help it, and all of these different so it's never been standardized that way. And I think that. When you go to a conference, for instance, my work, I was talking about the collaborators that I have, my work on this program, ISUT, was presented at a conference and in Germany. And I didn't go because I didn't have the money to go fly out to Germany. But I also, even if I had gone, I might sit at the talk that's on the work that I did a decent amount of and have no idea what anyone's saying. I would have no idea what the questions are because they're all speaking German. So I would have to, I'd have to learn German. And so all that being said, I was like, well, if I'm not going to get a master's, it'd be hard to get a PhD in it. But I think it's kind of fun to publish Egyptology journals and see like at the top of the journal, you've got your affiliation. I imagine people looking at that being like, oh, this work's cool. Like, what are they doing? And then seeing like Department of Evolutionary Biology, huh? And one of my collaborators is like, I think he's in the Department of Computer Science too. It's like, who are these people? And so I mean, hopefully people at a certain point, the work speaks for itself rather than the department or the title or anything like that. But I would say unless they standardize the language, it might be hard for me to end up being a Egyptology PhD. And honestly, I don't know if I'd want to go do a second PhD. As fun as I think this is, and I do think it's really, really fun, I think I'd rather do it on the side and build up my academic skills in the path I'm already on.
Cool. That's so interesting to think about. Right? What I was thinking about as you were talking was like, wow, I guess out of the three main countries of Egyptology study that you mentioned, I bet German students have a much easier time than the other countries because they learn English from a very young age because their school system. So they would only really have to learn French in addition.
Yeah, and I think honestly the French students probably have that same feeling too, where they just got to learn German really. Whereas I think it's hardest for the British and especially the American students because I would say before Egyptology, I probably knew like 0.9 languages, whereas they're up there with like 2 or 3. So props to them.
Wow. Okay, that was really interesting.
I feel like a lot of the time when I talk to people who are in the field doing work in their related major, at least when I talk to STEM majors in particular, I feel like I'm starting to notice a pattern where they all are really fond of humanities, and I'm glad to see it here too. So I was curious if you think studying humanities on the side just because you're interested in it has made you a better scientist.
Yeah, absolutely. That's 100% yes. I think that's a great question, and I think it's a great framing that I'm really happy to hear that observation that you've found that people interested in STEM having that fondness for the humanities, because I think at the time, I guess I'm not that much older than you are, but I think it was only a few years ago where people were kind of had this like idea of, and it still exists, but like that joke of like, oh, you're getting an English degree, like good luck at your Starbucks job, kind of like tone to things. I think people still have that joke around, but I think there's somewhat less of the STEM as like a hardcore, like, this is the only way to do things kind of mindset. People still definitely have it, but yeah, I'm really happy to hear that observation. And I think humanities has allowed me to think more creatively about things, think about things in this other way. I find that, and this is definitely going to sound counter to what I just said, but I'm not a huge fan of like philosophy of biology myself in terms of like, obviously all sciences has philosophy imbued in it. All science is overtly political, I think, but I think that there's still that part of me that's, the objectivity of science, that there's some level of that. I guess can uh, argue with how much there is, but I think that there is something there to distinguish them. But I think the beauty of the humanities in that sort of, I guess, more fluid, more like, I'm trying to think of the best way to think about it, like, thinking about Egyptology as a puzzle, right, where you're piecing things together, and, both the sort of actual language, but also this branching that back and saying, okay, what can we learn about the culture from this? That sort of like connection that's very natural for a humanities major, a humanities scholar, to say, what can we learn from this text about how the culture that we're studying has, viewed X, Y, and Z. I think that kind of framework is something that's less easy for biologists to say. And I think each evolutionary biologists, I think, is kind of like evolutionary biologists are good at that, I think, or better about that, because it's kind of branching that sort of thing. But, saying, when we learn about this cell, what can we tell about the organism? When we learn about this organism, what can we say about this broader process of evolution? How does it contextualize it? And a lot of that is, I think some people may be upset about this statement, but I think a lot of it's not as empirical as we'd like to say, or people would like to think. When you say, like, I observe this, there's an objective, or hopefully objective, or closer to objective observation, but then you project back and you make a theory. Okay, here's why I think this is happening. Here's my evidence for that. You're going a little more. But then when you make those bigger assumptions, like, and here's how I think that work, like it's the what questions, then there's the how questions, and then you've got these why questions. Why did this happen? Which I kind of go into that more humanities realm, which I think is really important to ask. Like, why does it even matter that we study, zombie flies or cat eye color development? Like, what's the point? And I think that to me is knowledge for knowledge's sake, for sure. But I think that humanities has definitely helped me with that. And I think, study is too strong. But I like to keep up with education literature, because I think it's really important to continue improving education and making education more accessible and, more suitable for everyone. And one thing that is more recent that has shown up is STEAM education. So we talk about STEM, putting in an A for art, and STEAM. Yeah, and art is not just painting and other sort of arts in that sense, but art meaning kind of standing in for all of humanities. And you get this misconception where people say, oh, STEAM education, well, like, okay, like, now what's the separation? Like, STEM plus all the arts and humanities is just everything you can learn. But I think the distinction is that STEM is the subjects, and STEAM is a way to teach those subjects. And so it's not saying we're going to lump art in with science, but it's that when we teach science, we should be teaching it in a way that we teach art, in this more free form, more creative, not rote memorization kind of way. And I really am very fond of the STEAM framework. I think there is an issue with it in the sense that we're not ready for it in some ways, is really my main objection. That I really like it, but if you give a STEAM framework to a teacher that's been teaching for 40 years, who's teaching STEM in like the hard STEM memorization way, and you just say, okay, now you've got to put art in your classroom, they don't have the training, they don't know how to do it. So I think my issue with it is more about the rollout, that like, and how it's been applied so far. But in theory, and I think hopefully in practice, as people find better ways of communicating this, I think my hope is that it'll be better. I mean, there are better ways to teach science. We know there are better ways to teach science, and I think that STEAM is one possibility in terms of bringing that humanities perspective and expanding the idea of what science is, rather than if X then Y, because it is so much more than that.
I really
That's so
appreciate
cool.
that you brought up the whole thing about distinction. um, separating arts from STEM, but because I feel at least, and I feel like Vanessa, I feel like you would agree with me, but I feel like the framework that comes from humanities, like for example, English majors, I think will separate STEM fields and call them analytical fields and separate humanities fields and call them art fields. But I feel like
Mm.
the humanities themselves are inherently analytical. Like I
Yes.
feel like any field that you're investigating has an analytical aspect to it. I feel like the way we ask questions in science is very similar to the way people ask questions in literature. Like somebody reading a book will see an element of the story and they'll be like, "Oh, where have I seen this before?" Or um, what is this similar to? What does this effect come from? How does this make me feel? And how did it go ahead and achieve that feeling? And I feel like it's important to call out the fact that humanities are themselves very analytical, and if anything, I feel like they have a more um, they they place a lot more emphasis on the framework of thinking and the ability to point out these patterns, and I think that aspect of humanities is incredibly applicable to STEM. Oh, Vanessa, you're about to blow up.
I I
Sorry.
I'm like vibrating in my seat. Oh my god, I'm so excited that you said this. Um, but it's when I did so last year, first semester of junior year, I got the chance to do a dual enrollment philosophy course. And what stunned me was just how analytical it was in nature. Because the way people disparage philosophy so much, but it's like from philosophy we get like our reasoning, logic, you know what I mean? Like that was the very basis of all science was philosophy, looking around and asking like why do we exist? Why do we do the things that we do? That was the basis of it all. And it is so analytical, especially the way things are just like formatted, like statements. With philosophical works, you define so many terms. If this is true, if this is true, if this is true, if all these things are true, then what do we make of this? What do we make of this? How do these factors interact? And that's something I've always found really interesting. And that in particular even sparked further my passion for STEM because I saw the connection so clearly after that class. So I'm so delighted that you brought this up, that it was taking everything in my soul not to interrupt you to talk excitedly about this class. But yeah, thank you for bringing that up.
Yeah, I think both of you bring up a really important point that like yeah that I is sort of most of this conversation I've been kind of drawing this distinction between the arts and humanities and the sciences and saying like there there are significant differences and you can use the framework from one to improve your understanding of the other, and I think that is true, but I think I'm very glad you pointed this out because I think it is really important to note that they are also not so different at the end of the day. And I think that there's like, so in some ways, an artificial distinction that's been made, that I guess societally we've made. And I think it's something that goes back a long time. And I think it's really interesting to see where fields fall in it because, there's historically been kind of a distinction between like hard sciences and
Mm-hmm.
soft sciences,
Yeah.
and it's also that also is very much related to a very gendered view of the world too. Unfortunately, where there's sort of been like the soft sciences are the realms of women, psychology and sociology and evolutionary biology. I mean, of course, when you think about the main figures in those fields historically, unfortunately, a lot of the women's names have been kind of moved off to the side. But a lot of the people doing that were women because that's what you were relegated to in a lot of ways. But as time's gone on, some of what was previously considered soft sciences have kind of slipped into the hard sciences, where like evolutionary biology flipped at some point. And I think hopefully as those gender dynamics are washed away over time, but also as people realize that they're not all that different, there's no reason to make that kind of distinction. I think, yeah, that talk about the analyticalness of philosophy, the analyticalness of English major analysis of texts and things like that. I think it will be really, yeah. I think it's a better world in which we understand that that's the case.
I think this might be very relevant to our audience, but I had a conversation with my boss, Ryan Robinson, who upon being a Renaissance man in literally everything. He also happens to be on the MIT admissions board, so that's the whole thing. And he was talking to me, and he was saying how, because I brought up humanities again, because I was reading. Hold on, I have the book in front of me. I was reading this book right in front of him, How to Read Literature Like a Professor, and he said he noticed the same pattern in some of his interns and people like my age that he's talked to, and he's also mentioned that a lot of the best applicants, especially when it comes to right out of high school, they're also having that same realization, or at least subconsciously acting on it. Like students who are good in both the humanities and the hard sciences are end up pursuing either path very well, and they have like a really robust frame of thinking. And what he said MIT was looking for was people who will use like a big selling point of college is not just MIT, but like a big selling point of colleges is that they're looking for students who will use their resources to make their dreams come true, or make the world they want to see happen. And I guess they seem to be finding that a lot more in people who have shown that they are resourceful and can learn from both the humanities and apply those skills that they learned in humanities-based classes like English, literature, and history, and apply that analytical frame of thinking to whatever STEM field they're going into, whether it's math, engineering, etc. And I feel like that like robust framework of thinking that comes from humanities makes people, I guess, resourceful, and by being mentally resourceful and physically resourceful, they become like better learners. So I think that's very relevant to like at least my demographic, being like a high schooler, and applying to colleges next year. As we're recording this, college apps are opening less than a week from now.
Yeah.
So, like,
Good luck.
Oh my God. Thank you.
Sorry, that just flashed me back to reality. I'm trying to stay happy. I'm happy.
No. Be happy. I'm gonna make you be happy right now, because we're literally almost done.
Oh my
We
God,
can focus, like in a couple months, in less than 6 months, that this is going to be the last time we ever have to do education for the sake of college, and we can just do education for the sake of education. This is great. This is an amazing point in our lives.
See, if I had known, if I had had the mindset that I have now going into junior year, I feel like I would have been a much more zen person.
Oh my God, right? Oh my God.
Right? Like,
We were
junior year,
insane.
I walked in, I was such a sweaty student. I was like, oh my God, I gotta get A's. I gotta get an A's plus. Blah, blah, blah. Like, I mean, I feel like I was on the lesser spectrum of it. There would be people who would get a 98 and cry because it wasn't 100, and I'd be like happy with my like 87. Like, oh, I did that.
In
let's
our
go.
grade?
Yeah.
In our grade?
Well, okay, maybe not in our grade.
Yeah.
The people who did it in our grade, they would suffer in silence, which I appreciated.
Yeah.
I didn't hear that. But especially with the grades below us, because I know you do TA work for them, but something we're noticing in the grades below us is that they, like, we call ourselves sweaty students, but they like
They're dripping.
they leave puddles wherever they go of just academic sweat and perspiration, and
Yeah.
they take it so seriously. Like, they're so competitive with each other. Like, scores will drop and they'll be interrogating each other. What you get on this? What you get on that? What you get on this? What you get on that? You talk to any of their teachers. I remember the grade below us, I talked to their chemistry teacher because we had them for AP chemistry, and I was just asking her, what's the grade below us like? Were we cooler than them? We were cooler than them, right? And she goes, yeah, because all they talk about is math. They go in the hallways, they're talking about math. They come in my class, they're talking about math. They ask me math questions when I'm not even talking about math or chemistry. They leave my classroom thinking about math. I walk out of school a little bit later than they do, but I'll walk out of school and they'll just be congregating talking about math. But like, and on top of that, a lot of them have that aversion to humanities. Not all of them, but like a good amount of them. So,
Yeah.
I don't know. That's just something to notice. But now that we have that senior mindset, as in whatever happens, happens.
Yeah.
Senioritis, yeah.
Exactly.
I
got
feel wizened.
senioritis.
May. Oh my God. I was on vacation after AP Research, because AP Research, you do your presentation at the end of April. We had 3 weeks until AP tests. Let me tell you, I was on vacation from English. My AP Research presentation is why I didn't get a 5 on.
Yeah. I remember the entire year in AP Lang. Well, not the entire year, but every once in a while, Vanessa would suggest an idea for an assignment, and not like in an annoying teacher's pet way. She was just genuinely interested, and so were we. So we ended up creating more work for ourselves. But I remember right after AP Research was done, our teacher comes in, he proposes a project, and she goes, "Guys, hear me out. What if," she leans on her desk and goes, "What if we just don't do it? Like, what if we just don't have to have a project?" And I looked around the room just to surprise, and everyone was agreeing. I was like, okay, well, I agree too. I didn't want to do the work, but I just didn't think that we'd have such a direct 180 after AP tests.
Cause like, what does it even matter at that point? Like,
This is true. This is true.
like, we weren't learning a new skill. We weren't even really practicing a skill we'd learned in the class because it wasn't necessarily related. It was literally just, we needed a grade for a final.
Yeah, that's true.
Yeah. That was such a fun period, though. I gotta say, though, coming to school really, like, shattered my soul because we would go and do nothing. So it's like, why am I waking up at 6:30 for this?
Well, and you exhausted all of your absences because you would leave early.
Well, no, I actually didn't. Oh my God, I had an absences scare last year, where randomly it showed through my viewpoint on the absences portal that I had 19 for a class, and I'm like, how can this be? Like, I literally haven't been absent that many times. But then I like gaslighted myself, and I was like, well, okay, well, it says here that I've been absent that many times. Like, maybe I have been. But it was World History 1, the easiest class, because I already knew most of it, because I find history really interesting. So one thing I do frequently is just watch crash course videos on random periods of time. So like, I knew most of it already. And I was just like, you know what? I guess I just have to suck it up. Like, I literally, because if you exceed absences, you fail for that class. So I was like, listen, I guess these 45 minutes each day are not worth it. It was the 9th period too, the final class. Oh my God, it killed me. You have no idea. Oh my God. And so then one day, I'm talking to the lady at the front desk, and I'm asking her like about my absences, and she goes, "Oh, but you don't have 19." And I'm like, "What do you mean?" I'm thinking like, oh my God, I have more? Like, I'm actually screwed, I'm cooked? And she's like, no, you only have 14 for that class. And I like freeze. Everything in me freezes. And I'm like, what are you saying? Like, what do you mean I only have 14? And she's like, yeah, you only have 14. Like, I don't know why. And then a teacher is standing there. Funnily enough, the AP Calc teacher who all the kids in the grade below us talk about all the time.
Oh,
it's his class they're talking about. He's standing right there, and he goes, "Oh yeah, that's a known bug with the portal. It'll show more absences on the user end than the administration end. The administration end is correct." And I'm like, "Are you serious?" And he's like, "Yeah." And I'm like, "You're serious? I can leave school again? I don't have to be here." So I took the last, I want to say, 4 days off. So school for me ended June 5th.
You know, one thing I'm starting to notice. Wow, this is I'm gonna do a really good job of reeling it back in. Hold on, watch this.
Okay.
So, one thing I'm starting to notice, at least when we're talking about high school, is just the fact that we don't want to be there. And I guess the reason your PhD experience is so shocking to us is because it's an environment that you want to be in, and everyone else there also wants to be in.
Yeah.
And everybody here, we don't want to be in high school. I mean.
Mm-hmm.
I guess that's reasonable. Like, we're all forced to be here, type of thing, and we're not learning the same things that we want to learn. So,
right.
I guess when I hear about like undergrad or even graduate classes, and I hear about your experience, it's kind of odd to hear somebody talking about school so fondly.
Yeah.
Because whenever we do it, it's just like, oh yeah, that's a thing we do every day because we have to. But for you guys, it's like you chose to be there, and you're happy that you're there, and you're pursuing your dreams while being there.
Hmm.
And
Yeah.
it's very hard to do that in the environment where we don't want to be. And I think it's also a lot less of an engaging environment. On top of the fact that we are stuck in a hole all the time. We're not that creative or anything. So um, that was a really insightful experience hearing about your PhD research and how the environment, the work culture is completely different.
Yeah, absolutely. And I think, I looking back on high school, I felt very much the same way. Like in high school, like I mean, there were things I enjoyed about it for sure, but there was definitely like it's like okay, I just got to go do the work, do the thing. Like Vanessa, your story about taking time off like reminds me of in there was an English class I had where he said, oh, like if you like we're gonna have a four-part final, but if you write a poem, you can skip one of the fourths, like a really long poem. He had like a thing, and so I wrote four poems for him, and I was like, can I skip the final? Like you said one fourth. Didn't work that way, but like always trying to find the way to like get out of things or like not have to do the like do the creative thing rather than the yeah, the thing where you just have to regurgitate what was in the book. And so yeah, I definitely resonate with that. I think looking back on it, I wouldn't say I'm glad for every part of it, but I think that there was some element of that stuff where I'm like begrudgingly like, all right, yeah, like I'm glad I got the general base I did. I glad I was forced to memorize this fact, or glad I had to read this book. But some things definitely like learning Latin like never helped me, never has helped me, and so I can still look back on that and be like, nah, not helpful. But for the most part, I don't want to say for the most part, but for many parts, it's only once you're out of it. And I feel like there's definitely got to be a better way where you don't have to look back and say, well, it sucked being there sometimes, but I learned something useful. Despite it all, I mean, there shouldn't be a despite there. And so, yeah, I mean, I think that's a educational problem, but I think but I definitely resonate with what you're saying. That every stage of my experience has been more and more freeing. From high school to college to grad school. I mean, once you get after grad school, like then it opens up big time in terms of like there's no restrictions really. And so like because post grad school there's do a postdoc, or you go straight into being a faculty member if you're really good, but usually it's postdoc then faculty member. And at each stage you get this extra freedom to control your own destiny, control your own learning. And yeah, I think it's that learning is really yeah, it's just so different. And hearing you talk about it, I'm like, I do not envy your position. but as Vanessa said, it's be over before you know it.
Yeah. I said that.
But not in those words, but you're like, yeah, you said basically that.
Yes, exactly. Thank you. First of all, Nathan, you really did reel it in. Wow. I'm impressed. Also, this has become such an uplifting conversation. Catch me in like November when it starts getting dark outside earlier, listening to this episode and being like, okay,
this episode.
I can see the light at the end. Okay, so I guess this brings us to your current research then, zombie flies.
Yes,
Tell us about what
zombie
you're doing.
flies.
We love
Yeah.
zombie flies.
Yeah, absolutely. So yeah, I guess I'll before the zombie flies. When I got to grad school, as I said, I was working with Hopi Hoekstra, who
Yes.
is a great behavioral geneticist and does more than just behavior. But I don't know if you've ever seen in a science class like that those pictures of those mice where like it's like a black mouse on a white background, a white mouse on a black background, and then the vice versa, and they blend in better. And so like they that's how their coat color developed. If you haven't seen it yet, and you take any biology class in college, you will see it.
Okay.
But she did that, but she's made her career on this genetics element and these like genetics of burrowing behavior. And I went to her lab to work, and I thought I was going to do 6 years on burrowing behavior and try to figure out, find a gene that contributes to burrow length variation. So one species of mouse has short burrows, one species has long burrows, and like what genes are affecting that and how. And so I thought I was going to work on that, and then I was a year in, and then she became the dean of the school. And when she became dean of the Faculty of Arts and Sciences, that meant, I guess, it means different things in different positions. But in her case, it meant that her lab had to wind down, and because now she's not really running a lab, she's running the department and the school. And so when in that transition, she basically said, "Look, like I'm going to have to wind down before you would have to graduate." And so she was very nice. She wrote me some letters of introduction. She said, like, "I will, support you in wherever you're going to go next, but you've got to find somewhere new." And so I did these, like, even though I wasn't a direct admit program, I was like, all right, well, got to find do some mini rotations. So I did some mini rotations around in other labs and other departments. And so, yeah, that's how I found zombie flies. And once I figured out that there was a zombie fly lab, I kind of was like, well, I'm probably going to end up there. And that's how it went. So I have been working on this, wow, almost a year now. It's been almost a year since she became dean. So I've been working on the zombie flies, and that's, unless my current advisor, something horrible happens, that's where I'll be for the next 4 years. And so so my research is so previously with the mice, it was genetic basis of behavior. Here it's more about the molecular basis of behavior. So the general zombie fly scheme is there's a fungus called Entomoptera muscae, and there's no common name for it. That's just what it's called. And a spore from that lands on a fly, and it burrows inside. It sticks out something called the germ tube, which burrows inside the fly, and it it has a cell wall, and like plants and many fungi do, except when it throws itself into the fly, it loses the cell wall. It just sends the inside of the cell out. And so now it's just kind of floating around in the inside of the fly, and it starts to eat up the insides of the fly. I guess we think. What we see is that the insides of the fly degrade and the fungus starts to multiply. We haven't seen it eating it, but we think it's using it for nutrients. And it eats only the fat body of the fly, which is a fly organ that's kind of like our fat, but it's a different kind of thing. But it eats up the fat body, but doesn't touch any of the vital organs, the things the fly needs to live, the guts, the gonads. It totally doesn't touch them. And it grows and proliferates and starts to fill up the fly. And it gets into the fly's brain. And at a certain point, the fungus starts to run out of food. And so it activates basically what you would call the zombification. It is in the brain and it does something, and we don't know what that something is, but it makes the fly do this behavior called summiting, where the fly will climb as high as it can right before death. So about 2.5 hours before death, it starts to summit. It climbs as high as it can, sticks its proboscis out, the mouth parts, latches on to wherever it is, and then it raises its wings, and then the fungus bursts out of its back. And it fires out of its back and rains down on other flies, landing on other flies, burrowing into them. Cycle begins all again. And so it's a really cool system for many reasons. But I think what I love about it is, it's how can it take over? How can it be behavioral manipulation so completely like that? And it's about as close to zombies as we really have. I don't know if people have heard of cordyceps, but cordyceps is another fungus that infects ants. And if you've seen The Last of Us, that's what The Last of Us is based on. And so it's fungus that infects ants. It gets into them, and it also manipulates them. They also do the summiting behavior. And this is actually something that you see in a lot of parasites manipulative parasites. They will make an organism summit. We call it summiting, but it actually sometimes goes down. So if it's above a certain, not in our flies, but with cordyceps, there's a great study that shows if it's above a certain place, I think it's 25 centimeters above the ground, it'll summit down. If it's below, it'll summit up, and it'll get to that same location, and then it will close its jaws on a leaf, much like how our flies stick their proboscis out, and then the fungus will burst out of their head. Except what's the difference, what makes our system so cool, not to put down the cordyceps system at all, but what I think is really the strength of our system is that unlike ants, flies are so well studied. I mean, people have studied ants for a long time, but our genetic knowledge of flies is better than basically any organism in the world, maybe barring C. elegans, which is a tiny little worm. But like, for instance, we know where genes are like have an order and on chromosomes and things like that because of flies. Like that, it was that original work is like the first genes discovered like that. And I think that, and ever since Morgan, who did win the Nobel Prize for that, it's been, the tools are crazy. So like, think about like, if you wanted to figure out a gene for a mouse, you'd have to do a lot of manipulation and stuff like that. Or like, let's say you wanted to make one singular mouse neuron glow. How would you do that? Well, there's a lot of complex genetics, but it would take a long time. If I wanted to make a certain type of neuron glow in flies, I would go online and search for that and order it, and it would come in a week. And like, you can't do that with other organisms. It's like, the tools are so great. And so they don't have that for ants. The other thing is in the ant, it's been shown that cordyceps goes into its muscles, but it does not go into the brain. So there still may be psychoactive compounds that are affecting the behavior, but ours has this really unique thing where it gets into the brain of the fly. So and it's not controlling their muscles at any point. Well, at least not directly, it doesn't seem. And so for that reason, with cordyceps, they've done a lot of studies about, what is the basis, like how is this fungus manipulating behavior? But all of those studies end up being correlative. It's like, okay, these compounds are higher during summoning behavior, or Wipfelkrankheit, which is what it's called. It's, I guess I do need to learn some German, but it means treetop disease. But it's that kind of, like these compounds are more present and they're not present over here, or like, but you can't really test it because they don't have the genetic tools. And, it may be that maybe it's just a physical thing. I mean, again, not to be dismissive about that, that would be really cool if it was just physical, but it's, with our system, I think there's so much to study, and it's really not been studied that much in the grand scheme of things. And so a lot of the modern work about, what is the mechanistic basis behind this manipulation is really from my advisor. And so it's really cool to be in her lab. She just started her lab in January of this year. So I was working with her when she was still a postdoc and still like, going to start her lab. So I think, she's done work in her grad school and in her postdoc on this, but it's cool to be at like a new lab just starting out, just getting into that. There's infinite questions to explore, and I love it. So my main project is trying to figure out what the molecule. I say molecule as if it's only singular. It could be multiple, but what molecule or molecules is the fungus producing that changes fly behavior? So we know from my advisor's work that there's a certain subset of neurons that's active during summoning behavior. And that projects down to a place called the corpora allata, which is where juvenile hormone is produced in flies. And it's the only place that it's produced in flies. And juvenile hormone is what regulates like transitions. So, a fly is a larva or an egg, then a larva, and then it becomes a pupa, and then it emerges as a fly. Especially like the pupal transitions, those are juvenile hormone has a big effect there. And so it seems like the fungus is producing more juvenile hormone, or making the fly produce more juvenile hormone, and that's making it extra active to do the summoning behavior, which is really cool. And there's more tests to be done on that side of things. But I want to know, all right, how is the fungus interacting with those neurons? Like, how can something totally, unrelated, well, I mean, it's related in the grand scheme of things, I guess, but a fungus makes something that activates the neurons of a fly is like, that's wild. And I think if I found a compound like that, one, it would be really cool for the system, and it would be really cool if it's the case there. Can I look for that in cordyceps now that once we would have something, I can look for it in other things. Is it a conserved thing across a lot of different species? Oh, I should mention that this is totally independently evolved from cordyceps, the manipulation. So they're like on separate sides of the fungal tree. And so it's totally convergent. And and so it'd be really cool to find that, but also, and I believe in basic science, and that you don't have to immediately, not everything has to have a benefit for humans immediately. Like, basic science is important because eventually things might be, discoveries in, bacteria or in other, microbes and things like that can always eventually, like, I think we found CRISPR 40 years before CRISPR became, gene editing capable, or we were able to harness it, or like mRNA was discovered like way before we could make an mRNA vaccine. And so I think I think basic science is really important, but I also do think that there's some transitions because we get manipulated by parasites all the time. And although we're not getting zombified, which is good, at least not now, definitely not going to work. But we do get manipulated a lot. Like, think about someone who has rabies who suddenly becomes afraid of water. And I mean, it's not quite the same fear of water, but they try to drink and they throw it up. They like don't want water anywhere near them. And you can think about it from rabies perspective, that rabies transmits by biting, and so if you're rabies, you do not want to get washed down because then you're not spreading. And so rabies is in manipulating the person to not drink water, or manipulating a dog to be really aggressive and go after people to bite them to amplify the spread. Or even something super simple that you don't really think about as manipulation, but think about something like poison ivy. If you're walking and you touch poison ivy and now you're itching, you're being manipulated to itch. Like, it's producing this sensation that makes you want to itch. And instead of and while you're itching, what you're not doing is killing that plant. And so it's also there's manipulative components there, and certainly not saying that all of those are the same mechanism, but learning more about how the fungus can manipulate the fly can help us learn about how we and other organisms can are manipulated. There's no better neuroscientist. No human is a better neuroscientist than Entomoptera muscae is. Not even close. And so being able to know how they're doing it, can give us some significant insights into that. So I think, to me, that's the distillation of it. And of course, I'm also bringing the reason I work with the island flies is because I want to bring like an evolutionary component. I want to test other types of flies and all these sorts of things. But yeah, that's the general overview.
First of all, that was very cool. Secondly, what was that word you said? Entomoptera muscae?
Yeah. So I could type it. Let me see if I can spell it. ENTOMOPHTHORA space MUSCAE. Yeah, that sounds right. I had to memorize that for my qualifying exam. Because it would be really embarrassing if I spelled the species that I work on wrong. It's probably an instant fail.
They ask you how to verbally spell things?
Oh no, I'm screwed.
Yeah. They don't, but they did ask me to draw a tree of fungi and put my species on there, and I was like, yeah, if I draw a tree and I spell it wrong, they're gonna be like, fail this guy. And yeah, the stakes aren't this high, but technically, if you fail bad enough, they can kick you out of the program. So like, you definitely didn't want to press my luck on that one.
Yeah, for sure.
Mess up, right?
Yeah, so it depends on how bad you mess up. If you came in and they asked you a question, you were just like, nah, you're gonna pass me, and didn't say anything, they might kind of retaliate against that. But if you try your best and you're just not quite up to the standard, or you have other circumstances, yeah, you can definitely take it again. I know people have taken it again. Some people have taken it even twice more. But if you really just can't, if you really show that you're not, up to their standard, even with whatever else, or you're not putting in the work, because it's really about putting in the work. I mean, determination, going back to that, like succeeding in grad school the if you had no other quality other than determination, you can get a PhD because like it's just about hard working it. But if you aren't interested in it, yeah, they might fail you and kick you out. But people have, I think, a little bit of an undue freaking out about the qualifying exam because it is a 3-hour exam, 3-hour oral exam. So no one really likes that. But yeah, I still felt it was important to spell it right.
This is like such an uplifting conversation. Like I don't know about right? Like right? Oh my god, yeah. Like I don't know.
The grass is really green.
Yeah, it's been a beautiful couple weeks recently. That I'm now just noticing. But no, cuz like I don't know, it's like there's a difference between knowing there's a light at the end of the tunnel that is high school. Like, you know what I mean? The tunnel is high school, the light is, I guess, further education. There's a difference between knowing that it exists and getting an understanding of what its existence will mean for you. You know what I mean? So this is so cool.
And I think your podcast is a great idea in terms of bringing that kind of perspective to that. I would love to, like, it's something I've actively tried to seek out is the ability to share that, because like I would have loved in high school or college, like, you know, I did some research, but to have someone say like, here's the deal, here's the path, and like, they just don't get that. At least I didn't.
Yeah, it's invaluable information, and I wish like someone made it before us. You know what I mean?
Yeah.
Like I would have listened to this in 9th grade. I would have been excited and like glad for this in 9th grade, but I guess you always have to start somewhere. So, but yeah, I'm glad because that's honestly our goal with this is that as we learn, we can hopefully be able to, I guess, document and catalog this knowledge and these findings for other people in our age who are in the same situation, that it might be easier for them, and that as a collective we can begin to approach our futures with more efficiency and like joy.
Yeah.
Thank you. Oh my god. Oh my god. But yeah. Thank you. That was great. Also, like, you answered like every question that I had, you would just preemptively answer, and I thought, oh, okay. Like, I was gonna ask you, like, what are the implications of this work? Halfway through even having the thought, you're talking about the implications. Like,
see, I have a notebook that I bring with me for every meeting, and it's just you can barely see it, but it's just filled with half bullets because as
right?
you write something down, you would say something like, for example, I was gonna ask you what parts of the fly does I can't even pronounce. I'm not even gonna try.
Sure.
What parts does it consume first, and like what's the logic behind it? And as I was writing it, you go into detail about how it consumes that body first, and then everything. I was like, oh, okay, all right, thank you. Same thing with the points. Like every once in a while, I look back to see just to make sure that we're kind of on track, and to be like, oh, he already got this and this and this. I guess all we have next is zombie flies. But no, this is a really productive conversation, and I really like.
Yeah. Oh my god.
Develop ideas and the way you do you teach?
I try my best to. Depends on which undergrad was reviewing me at the time. But yeah, so in my program I have to teach. It's actually most programs you teach once or twice. My program you actually teach 6 times, which most people kind of are like. I wouldn't say most people, but many people are like, that's just like, that's so much teaching. I just want to focus on research. And while I also want to focus on research, I think teaching is really important, and I really enjoy it. So I try my best to teach there. And also we have started, Vanessa knows it, but we started a program for high school students to come in to labs and do research there. And yeah, I'm also trying to implement some pedagogical material in that, so it's not just wandering around aimlessly on campus.
Can you talk a bit about that program? Are you allowed? I don't know if it's under wraps.
No, I absolutely can. I think as of now, I would say it's one step beyond a pilot program. So we basically, when I came to the university, it was kind of like, well, it's it doesn't seem like there's a lot of outreach work being done. And I think what's really frustrating to me is that there's so much cool research, and there's just nobody knows what's going on. Like, talking in this setting is a great place. Like, it's sort of like, disseminating knowledge, not just about the science, but the scientific process. What does it mean to be a scientist? And it was really sad for me to see that there had been no program ever reaching out to high school students in this way in my department. I mean, some of the museum that were connected to the Harvard Museum of Comparative Zoology, there's definitely outreach work there. But in terms of the actual researchers, maybe individual labs did things, but not on this bigger scale. And especially when we have a public high school literally 5 minutes away by walking, and they had never ever come, and like in a formal way. And when we did have some students come through, there was really a kind of pessimistic tone of like, well, Harvard's not, like Harvard's cool, but it's not for me. And it's and I remember talking to a woman, and she was saying like, well, yeah, like I didn't, like she's like, I don't think I could get in. And I was like, well, why not? And she was like, yeah, like I just don't think I'm at that level. And I talked to her, and she had like, like a 4.0 GPA, and she had like a ton of extracurriculars, and she had like, she had like a lot of like things that Harvard, I think, wants in its community, and she knew the area, and she had been there for like a summer program too, and but it still like didn't click that like she could do it. Like it is like, and I think what I would say to people listening to this is like, even if you don't have a 4.0 GPA or all those extracurriculars, it still can be for you. And I think like, but it's sort of it was stark that even someone who like on paper, like, you could read their CV or whatever and resume and think like, oh yeah, like seems like a good fit. Like it's not that internal feeling of belonging. And I think, I know plenty of people that even here who are at Harvard have that imposter syndrome. So, but I think part of it is that experience, like, oh yeah, actually like going and being in the labs, like realizing that people at the school are just like normal people who like mess up and like, botch experiments and, but also are, doing really cool, fun stuff, that it is like it can be for you. And I think that, so I started this program, which was based on a framework that already existed, but it hadn't been ever implemented. And so we made these contacts with the local high school, and there's a teacher there, Paul McGinnis, who taught marine biology. And so he wanted to get his students exposure. But again, like basically what he was doing was having students come and placing them into labs for internships, which is nice and really important. But the problem is that was only the students who did see themselves as, yes, I can do this. I want to do research. It wasn't the students who didn't even cross their mind. And so the way way I thought to start the program was to have this one day where it was originally titled Marine Science Day. Now it's Evolution Day because we've expanded to other classes. But students come in for a day and rotate through labs in the fall, and they just kind of like do these like 20-minute rotations, see what research is going on, just to get acquainted with them. And it has a dual purpose where it gets the labs to know what students are like to work with, because a lot of people just don't. And then also have the students understand what a lab environment looks like and stuff like that. And then in the spring, we have the students come in for the internships and have those matches. And that, I think the innovation there to me is that the program, we got the high school's approval to get the program for course credit. And so I think that's important because a lot of students who want to do research, or just went and visited and got inspired and said, oh, maybe I could do research, can't, because a lot of programs are after school, and maybe you have to work or take care of a relative, or like students don't all have the luxury of that after school time, or it might be on the weekend, which is sometimes even worse, or the summer, which sometimes students have to work through the summer, or go somewhere else. And so it's with having it during school, if you already have to be at school, then during the school day, walking over or getting over to Harvard and then being able to do the research, I think is really important, and it makes it much more accessible in a way that a lot of these other programs aren't. And so that's the idea behind the program. And so upside is that, it's working really well. I think we had 80 students come and visit, and we had 8 of those students end up being placed into labs. So it's 10%, which is very good for these programs, I think. And so, but we just got an internal Harvard grant
Nice.
to expand the program. So it's a yeah, it was good. It's definitely the biggest grant I've gotten so far. Hopefully not biggest in my career. Knock on wood on that. But I was really excited about it because it means we can expand to more schools and more labs, and hopefully get other departments like people interested in climate change or in chemistry, and it's not just biology in this way. And yeah, and so fingers crossed this year it'll go really well. We're hiring more people to help run the program, and the only downside is because it requires this school integration. There's a big admin barrier where like Harvard admin and school admins, where you have to get them into the same room, which is hard to schedule anyway, and then they have to agree, yes, they can do it for school credit. What does that look like? What kind of, how are they going to get, how are students going to get educational attainment in X, Y, and Z ways? But it's definitely worth it to do. And so hopefully we'll expand it beyond the current Cambridge Ringe and Latin School, expand it to Boston Public Schools, and going out, because I think the people who are have the least access are in Boston, and then out in this outer ring around Boston, the Lawrences of the world, or the Revere and stuff like that. But areas like that, who is doing outreach out there? It's like kind of nobody, which is really sad because
Yeah.
everywhere has students who should be getting opportunities like that. And we have the capacity. It's just people need to do it.
This is so great to hear. This is like a genuinely so uplifting to hear. I love programs that do this. The program I'm doing, I'm just gonna talk about it because by the time
Yeah.
this comes out, it'll be long over. But I'm doing the Cure program run by the Dana-Farber and Harvard Cancer Center. It's a paid internship, which is so important to like people in my position, because I think this is the case for the majority of high schoolers. We don't have the time or money to waste to do an internship in most cases. Like, we don't have the liberty of using the time we have during summer break and using it for something other than working, which I think is so important. And especially, it's like what you said, where you have to be at school. You have no choice. You have to work otherwise. And you've considered that completely in your schedule. It is specifically made for students in those positions. It's great. I just love to hear it. It makes me happy to hear. We need more programs like this.
Mm-hmm.
I think the most important thing for students, I guess, in a transitional period, like going from high school to college, or going from high school to the workplace, or just starting their careers in general, is perspective. And I really appreciate groups that take the initiative to give people that perspective, like the way you're tackling it, giving students who otherwise wouldn't have the opportunity to work in a lab or even talk with people who are professionals in the field, giving them the opportunity to actually have that experience that most people don't get until undergrad. Or the same thing with the Cure program, how it's giving students a great opportunity and a sustainable opportunity, as in like it's a paid internship, to actually learn in the field from people. And I think that's very important. I think that's something I think that's a long-term goal I have with this podcast, to give
Yeah.
students that perspective. So I don't know. I think that's really cool, and I think that in itself is very uplifting. Like, I think I'm feeling that like right now, just the fact
Yeah.
that I've been able to get that perspective. I feel like, oh, like it's like a rock has been lifted off my chest.
Genuinely. Oh my god.
I guess like the best way to explain that is I guess part of the fact that I don't know if I got this from you, Vanessa, but I feel like whenever I'm in a period of like transition, I don't know what I don't know. Wait, I don't know. What
Yeah,
I'm
we did
confused
talk about that.
Yeah, okay, so I did get it from you.
Yeah, yeah.
But it's kind of like not having the opportunity to get to know, or not knowing, feels like a burden. And it's such an elementary step. Like, it's not like you did anything for us other than just give us your story. But it's the fact that you gave us that perspective from talking to, or we got that perspective from hearing what you had to say. and like maybe someone listening to this podcast, I hope, can hear what you're saying and then be like, this guy seems like a very likable, normal human being that and I like his position, and I want to do that. Like, that's something that you can really only get from talking to someone, and
Yeah.
that's like a really, it feels like a really, how do I say, like, no, there's a word for this, guys. Hold on.
I know what you're thinking, and you're like, wow, knowledge really is power.
Yeah. Thank you for that.
Yeah, no, I don't know what word you were going for, but I know what you meant.
She caught the vibe. She caught the vibe.
Yeah,
Yeah, yeah, no, I totally get what you're saying. I think people kind of look down on like networking in science, I think a lot of the time. I mean, people talk about it as important, like, oh yeah, like if you're a grad student and you go to a conference, like, yeah, go talk to like that professor that you think you might be interested in doing a postdoc with, because you got to get that in or whatever. But I think it's a lot, that's not the type of networking that I think is, when people say networking, that's not really because we don't use generally like LinkedIn, for instance. Vanessa knows, as I didn't update my LinkedIn for, many years. And I think it's sort of like, because it's like, oh, who cares? We're in our little ivory tower doing our research. But I think that it's a really nice, I think it's a really nice thing to just get perspective. Like I feel that way. Well, I have felt that way many times, but I still feel that way. Like when I have the opportunity to talk to like a professor who has a totally different, like from a totally different background, or like has a totally different path. And it's just like, because like, as anything I've been able to say about here's what it's like to be a professor or a postdoc or something like that, that's not experiential. That's knowledge that I'm distilling from talking to people who are, at this other level. And I think at a certain point, it's easy to get there. Like I'm working in the lab, I see postdocs all the time. I see professors all the time. One thing I love about science is people say it's non-hierarchical. I don't believe that. I wish it wasn't, but there is still hierarchy there. But there is a different type of, it's a lot different. Like I call professors by their first name, even if I haven't met them many times. And it's just sort of like, it's just how you do it, which is like, it was hard to get used to for sure. But I think like that, that sort of familiarity is really nice. But and in college, maybe you get a little more of that. You work in some labs, you meet some grad students, something like that. But, there's a huge barrier with like high school, like as you're saying, like your networking group, I think is great because I think and this podcast, it's sort of like how else, like I would never be able to, if I hadn't made the connection with Vanessa through HPrep, like I would never be here probably. Like I think it would be really unlikely that, I mean, certainly if someone had reached out to me, if one of you had cold emailed me, I certainly would have done it. That would have been great. But like, I can imagine it's probably a barrier for you, and reasonably so, to like email every grad student online and just hope that one says
Yeah.
yes. Honestly, I think you'd get a lot of yeses, but I think like it's, how do you know, right? Like, and I
Yeah.
think it's, yeah, having that connection, like, it's not just on you to have to, on the high schooler or the person who wants the knowledge, because as you said, you don't know what you don't know. Like, how would you even know to email a grad student? Like, I wouldn't,
Yeah.
what is a grad student, right? And so I think like, I mean, I still think what is a grad student, but I think like the higher you go in that academia ladder, the more you, I think it's important to deliberately go and like talk to people and make those networking connections to like, yeah. So like I think certainly if anyone listening to this is does have extra questions beyond whatever I've said now and whatever we're going to say, in the remainder of recording, like you can definitely direct them to email me. Like I'm always happy to take emails, questions. Please reach out, because I think the most important part of science, like even if I did, wonderful world-changing work, if I don't inspire anyone else to do the same thing, or I don't give any help to anyone doing the same thing, the amount of impact that I have as a person, but also that science has, like that disappears in a generation if you don't help others people.
Yeah, we'll be sure to include that wherever we have no idea like where this is going to end up,
So
like streaming wise.
SoundCloud.
easiest place to
Probably.
get it would be either SoundCloud or Spotify, and I know like there's like episode descriptions.
Right.
There's
Yeah,
episode
that would
description,
probably.
So we'll probably put information
Perfect.
about like the plot and then how to contact our guest, how to contact us.
Cool.
Wow, you know what? Around 45 minutes in, you had gotten through three
Dang, we are
of
2
our.
hours in.
We're 2 hours. What?
Oh my
Oh,
goodness.
Nathan's seeing his future for the next 2 days in its editing. Although, to be fair, there's going to be very little editing on this. You said lots of, like, substantial things to the point that, like, what is there to cut out besides,
feel
like,
wrong to cut it out.
ums?
Yeah, you can cut out my arms. You can cut out the random loop tangents.
No. Those are crucial.
It's part of the process. It's part of the process. They need to know we're not robots. We're human beings.
Yes.
Yeah.
45 minutes in, we were 3 out of the 4 discussion points in, and I was like, oh my god, how did we get through them so quickly? I did not need to be afraid. There was nothing to fear.
As the person doing the first round of editing, at that same time, I also looked at the list and I saw that we got through in 45 minutes. I was like, wow, I wanted more, but I'm fine because I only have to edit a certain amount. And I guess I could keep some of the length. You know what? No, I think I'm gonna have dang, my body stopped me from saying it. I think I'm gonna have a fun time editing this one.
It said, do not lie. It said... No, actually, I'm gonna watch this after we stop recording, so this is gonna be my afternoon entertainment. But yeah, so I guess that about wraps it up. Like,
Wow.
I'm shocked.
Yeah, I mean, you go ahead.
I think Vanessa was right when she said we should have Julius on the pod. I don't know which of the time she said it that I agreed. Like, yes, we should do it. I think I agreed first try, actually. But
yeah, there was no question.
kudos to you, Vanessa, and kudos
Thank
to
you,
you,
thank you.
Julius, for having you here, for coming here and telling us your story. And
Yeah, thank you so much.
Thank you, and thank you
Oh,
for
man.
responding to my copious emails with help about
Absolutely.
essays.
Yeah, see, there's another value of networking, right? Like, I love reading essays because what it means is that I don't have to write my own things. There's a slight bereave from that. But yeah, definitely always happy to help. I mean, although if you're listening to this, maybe don't send your first email to me with a bunch of essays for me to read. Once I know you, then it's okay.
Yes, this is HPrep mentor privileges, okay? Apply to HPrep or a program that is similar in your state if we are having... I have no idea what our demographics are going to be. Like,
Oh yeah, because
probably young.
As we record this, we still haven't posted our episode
At all.
I have come up
Like-
with some ideas for advertising though. I have way too many ideas. I came up with them in the past 2 hours actually. I sit in the shower and I think about how we're gonna advertise.
That's where all of everyone's best thoughts come from. I'm telling you, my AP research project, the vast majority was derived as a shower thought. But with that, I was like, let me get Nathan a waterproof notebook for Christmas.
Dude.
Well, but now it's not a surprise. Oh my God, why did you say anything?
I forget.
You're gonna edit this. You're gonna remember.
Oh shit. You can edit it out if you want, and then I'll go in.
So I guess we can wrap up. Yeah.
Okay.
Yeah. Wow. Do you want? Oh wait. I guess we
Yeah,
usually
you have
do
the
a
same
thing.
realization as I didn't do.
We do a thing where we go. Oh my God! I can't believe we're admitting to this. We do a thing.
No, it's okay. I'll save you from this, Vanessa. I'll say it. So we haven't come up with a good outro yet. So what we've been doing is trying our best to do it in unison, but we never do. It's always horribly off topic. Oh, Vanessa's dead. Okay. And we scream business out as loud as we can. Well, not loud, but right into the mic. We scream business out, and then we kind of, it's like a mix of screaming and barking, and then we just kind of halfway through.
I like that outro.
One thing I told Nathan when we were initially emailing you, I was like, do not embarrass me in front of Julius. But we've done it ourselves.
Oh my god.
Is this something you're gonna do and I'm gonna watch you do, or is this something you want the guests to be involved in as well?
Oh,
I mean, would you like to be involved?
Well, it depends on how your formatting is. I'm happy to bark at somebody.
This is not real.
the
This
best
is a dream
timeline.
sequence.
This is the best timeline.
We rarely say that. Okay.
Oh wow, I'm crying.
So, I'm gonna let Nathan count us off because he's
Well,
maintaining his composure.
Okay. So, I guess we could try to do a countdown. It'll not. It's really hard to take me seriously because I can hear myself echoing.
Is the countdown 3, 2, 1, go? Or okay.
Okay.
Wait, is it? What's our countdown?
3, 2, 1, and then on go. Like instead of saying go, we'll just start.
Okay.
And we'll just go business out. This is not real. Okay. Okay. Embarrassment isn't real. It's all a sham, and it's just a bunch of chemicals in my brain that will leave me soon.
Right, exactly.
Right.
Yeah. Yeah.
Count us off.
Okay. I'm gonna do it with fingers.
Thank you.
Business
Out.